Today we are using calculus to talk about displacement, velocity, and acceleration. First of all, we have to talk about the difference between the distance and displacement. The distance is a scalar quantity that refers to how much ground that you have traveled, and the displacement is a vector quantity. You can see the difference between distance and displacement in this graph. From the point A to B is the displacement. Let's say it's 2 meters. From the point between A and B going with the path C and D, we have the distance. It may be 4 meters or more. The difference between the distance and the displacement is that the displacement is a vector and the distance is all the quantity we have traveled. The second one we have to speak about the speed and velocity. The speed is the time rate at which an object is moving along a path, and the velocity is the rate and direction also of an object's movement. For example, an object is moving from point A to B with a velocity of 5 meters per second in this direction. And if the object is moved backward from point A to point C in this direction with the velocity of 5 meters per second, we have to say that the velocity is negative 5 meters per second. But in any direction, the speed is 5 meters per second. So the speed is the rate of changing of an object moving along a path. No matter which direction, the speed is always positive. And the velocity of the vector factors, so it has positive and negative value. First, we talk about acceleration. Acceleration is the rate at which the velocity changes with time in terms of both speed and direction. So we have the formulas. The mean acceleration is the final velocity minus the initial velocity over the time. The time unit is usually second, and the velocity is usually the meter per second. So the unit of the acceleration is meter per second squared. We use s for displacement. And s is always depend on the type. So we have the s is a type function. For example, we have 3t to the creep minus 5t plus 2 equal to the displacement. We use v for velocity, and the velocity is also a function of t. And if we differentiate the displacement function, we got the velocity function. So for this example, if we differentiation st equal to 3t squared minus 5t plus 2, we have 3 times 3t to the square minus 5 equal to 9t squared minus 5. We use a for acceleration, and a is also a function of t. If we differentiate the velocity by t, we got the acceleration function at. For the above example, if we differentiate 9t squared minus 5, we can have 2 times 9t, 18t. It's also a function of t. So these three terms we are talking about today is the displacement, velocity, and acceleration. Then we will use calculus to solve an examples of displacement, velocity, and acceleration. Question 1. If the displacement measured in meters of a particle moving in a straight line is given by the equation of the motion. St between 0 and 5 seconds. The function st is equal to 5t squared minus 3t plus 6. T is measured in second, s is measured in meter, v, velocity is measured in meter per second, and acceleration is measured in meter per second squared. T is from 0 to 4. And after 4 seconds, the particle stops the acceleration because it's run out of energy. We plot the graph of st, plot the graph of vt, and plot the graph of at. We find the velocity of the particle st equal to 3 seconds, and we find the acceleration of the particle st equal to 2 seconds. And when the velocity reaches 150 meters per second, what is the time t? And what is the acceleration at time equal to 4 seconds? And time equal to 6 seconds. What is the velocity as t equal to 4 seconds and t equal to 6 seconds? And finally, what is the displacement of the particle as t equal to 4 seconds and t equal to 6 seconds? Plot the graph of st. First, we draw a table of s and t. T from 0, 1, 2, 3, 4, 5, and 6. Since st is equal to 5t squared plus 3t plus 6, t is from 0 to 4. When t is equal to 0, s is equal to 6. When t is equal to 1, s is equal to 14. When t equal to 2, s is equal to 52. When t equals 3, we substitute 3 into t cubes. T, we have s is equal to 150. When t equals 4, s is equal to 338. But when t is equal to 5 and 6, we cannot use this function any longer. So we don't know what is s when t is equal to 5 or 6. Now we are going to plot the graph. When t is equal to 0, s is equal to 6. Draw a point here. When t is equal to 1, s is equal to 14. The point in here. When t equal to 2, s is equal to 52. The points around here. When t equals 3, s is equal to 150. The point around here. And when t is equal to 4, s is equal to 338. Point around here. So we draw a curve, and this curve is st equal to 5t cubed plus 3t plus 6. But this curve is just up to the point when t is equal to 4. T is equal to 4 or greater, the function will be changed because the function of st is no longer 5t squared plus 3t plus 6. Part B, we plot the graph of vt. Since we know that ds by dt is equal to the function vt, and s is equal to 5t squared plus 3t plus 6, t is from 0 to 4. We differentiate this equation once. We have 3 times 5t squared plus 3 is equal to 15t squared plus 3. And then we draw a tables of t and v. T is from 0, 1, 2, 3, 4, and 5. When t is equal to 0, v is equal to 3. When t is equal to 1, v is equal to 18. When t equal to 2, v is equal to 63. When t equals 3, v is equal to 138. When t equals 4, v is equal to 243. And we don't know what is v when t is equal to 5 and 6, because the function of vt is just from t is equal to 0 to 4. Now we plot the graph. The vertical axis is v, measured in meter per second. Horizontal axis, x-axis, t is measured in second. And the marking point is 1, 2, 3, 4 to 7 seconds, 100, 200, and 300 meter per second. When t is equal to 0, v is equal to 3, point around here. When t is equal to 1, v is equal to 18, the point around here. When t is equal to 2, v is equal to 63, points around here. When t equals 3, v is equal to 138, the point around here. When t equals 4, v is equal to 243, the point around here. Now we can draw a graph vt. Vt is equal to 15t squared plus 3. T is from 0 to 4. But after 4 seconds, we haven't got the function of vt, so we cannot plot the graph after the 4 seconds. Part C, plot the graph of at. Since we have vt is equal to 15t squared plus 3, t is from 0 to 4. We have dv by dt equal to at. We differentiate this equation, we have 2 times 15t, so it's equal to 30t. Now we draw the table of t and at. T is from 0 to 6. When t is equal to 0, a is equal to 0, 30, 60, 90, 120. But how about when t is equal to 5 and 6? Because from the version we know that after 4 seconds, the particle stops to accelerate because it's run out of energy. So after 4 seconds, the acceleration of the particle will be 0. So this will be 0 and 0. And now we plot the graph of at. The x-axis is t, measured in seconds, 1, 2, 3, 4, 5, 6 seconds. The y-axis is a, measured in meter per second square, 100 meter per second square and 200 meter per second square. When t is equal to 0, the acceleration is equal to 0. When t equal 1, the acceleration is equal to 30 and 60. So it should be a straight line until t equal 4. But from the question, when t is equal to 4 seconds, the particle stops to accelerate. That means the acceleration will be 0. So at the point t equals 4, the acceleration will be 0. This function never touches this point here. This function at equal to 30t never touches this point. As t equals 4, the acceleration will go down to 0 here. So the acceleration continues moving in this direction. So the graph is in here. We can write the AT equation as AT equal to 30t, where t is from 0 to 4, and A is equal to 0 when t is greater than or equal to. Part D, we calculate the velocity as t equal to 3 seconds. Since we know that the function of Vt is equal to 15t squared plus 3, so as t equal to 3, V of 3 is equal to 15 times 3 squared plus 3, equal to 135 plus 3, equal to 138. And the units will be meter per second. Then we calculate the acceleration as t equal to 2 seconds. Since at is equal to 30t, as t equal to 2 seconds, a2 is equal to 30 times 2, equal to 60. And the units is meter per second squared. Part F, when the velocity Vt is equal to 150 meter per second, what is the t? Since we know that the Vt is equal to 15t squared plus 3. At some time t1, the velocity will be 150 meter per second is equal to 15t1 squared plus 3. So 15t1 squared plus 3 is equal to 150. And t1 squared is equal to 150 minus 3 divided by 15, equal to 147 divided by 15. So t1 is equal to plus and minus square roots of 147 divided by 15 is equal to plus and minus square roots of 9.8. So it's equal to plus and minus 3.1305, correct to 4 decimal points. And we know that t1 cannot be negative because the time cannot be negative. So t1 is equal to 3.1305. So in conclusion, as t is equal to 3.1305 seconds, the velocity will be 150 meters per second. We can also compare the table here because 3 seconds the velocity is 138 and 3.1305 seconds the velocity will be 150 meters per second. So part G, the acceleration as t equals 4 and t equals 6. Since we know that at is equal to 40t, as t equals 4, a is equal to 120 meters per second squared. And when t is equal to 6 seconds, from the question we know that the acceleration after the 4 seconds, the particle stops to accelerate. That means the acceleration after 4 seconds will be 0. So when t is equal to 6, a is 0 meter per second squared because no more acceleration at that point. In part H, we calculate the velocity as t equals 4 and t equals 6. Since Vt is equal to 15t squared plus 3, t is from 0 to 4. So as t equal to 4, V of 4 is equal to 15 times 4 squared plus 3 is equal to 15 times 16 plus 3 is equal to 243 meters per second. But how can we calculate the velocity when t is equal to 6? Since we know that as the time is equal to 4 seconds, the acceleration is equal to 0. And we know that dv by dt is equal to at and equal to 0 when t is equal to 4. Thus dv equal to at dt, and we integrate both sides. Vt should be equal to a constant, but at the time when t is equal to 4, from the above equation here, we got the velocity will be 233. So Vt should be equal to 233 when the time is greater than or equal to 4. That means it is a constant speed because the acceleration is equal to 0, so the velocity is a constant speed. So after 4 seconds, the velocity is a constant speed. So at time equal to 6, the velocity is also equal to 243 meters per second. Part I, we solve the displacement of the particle as time equal to 4 seconds and t equal to 6 seconds. Since we know that the function of st is equal to 5t squared plus 3t plus 6, t is from 0 to 4. So as t equal to 4, s of 4 is equal to 5 times 4 to the cube plus 3 times 4 plus 6 is equal to 348 meters. After 4 seconds, the velocity will be constant, equal to 243 meters per second. So as time equal to 6 seconds, so as t equal to 6 seconds, the function of st is equal to st minus 2 plus vt, where vt is this function here. So as s6 is equal to s6 minus 2 plus v2, equal to S4 plus 2 times 243, where S4 is 338 meters. 2 times 243 is 486 meters. The answer will be 824 meters. So in conclusion, when t is equal to 6 seconds, the displacement is... We have done all parts from A to I. So this is all for today's lesson. For revisions, today's lesson is the displacement, velocity, acceleration, with differentiation between the distance and displacement, speed and velocity, and finally the acceleration.